So I wanted to finish up the examples that I had started in class on Tuesday. So this one is number 19 on particle motion. A particle moves along a line so that its position at any time t greater than or equal to 0 is given by this function. So we have s of t equals t squared minus 3t plus 2, where t is greater than or equal to 0. So then we're asked, and S is in meters, T is measured in seconds. So we're asked to find the displacement during the first 5 seconds. So the displacement is just going to be my ending position minus my initial position. So that's just going to be S of 5, where it ends after 5 seconds, minus S of 0, where it started. So if you plug in a 5, we get 25 minus 15, so 10 plus 2 is 12. And if you plug in a 0, you get 2. So subtracting, we get 10. And S is measured in meters, so this would be 10 meters. So that's the displacement. Part B asks us to find the average velocity during the first 5 seconds. So remember, the average velocity, not instantaneous, but the average velocity is your change in position over your change in time. Well, our change in position we just found, but I'm going to go ahead and write it out this way anyway. And our change in time, so we get 10 over 5, which is 2, and this is going to be meters per second. So that would be our average velocity. Part C asks us to find the instantaneous velocity. So now we're finding v of t, which remember is the derivative of position. So we get 2t minus 3, just using the power rule. And then we want to know what v of 4 is. So we substitute in a 4. And 8 minus 3, we get 5. And this is velocity. So it's meters per second. So you got to make sure you remember units on these problems. That's going to be a big deal. Part D asks us to find the acceleration of the particle when t equals 4. First I'm going to find the acceleration. And acceleration, remember, it's the derivative of velocity or the second derivative of position. So we get 2 using the power rule here. And that would be meters per second squared. And then A of 4 is also 2 meters per second squared because it's a constant. So that is part D. Part E asks, at what values of t does the particle change directions? Okay, well, remember that when v of t is positive, then the particle is moving to the right. And when v of t is negative, it's moving left. So at what values of t does the particle change directions? Well, it changes directions when it goes from moving right to moving left, or if it goes from moving left to moving right. So when it switches from being positive to negative or from being negative to positive. So that's what we're looking for. So we want to find the 0. So we need to know, well, when is v of t 0? So I'm going to set that equal to 0. 2t minus 3 equals 0. And when you solve for t, you get 3/2. And then I want you to notice that if I'm going to make a little number line chart here. If I plot my 3/2 right here, if t is greater than 3/2, like say a 2, and if I plug a 2 in, I get 4 minus 3 is 1, which is positive. So on this side, it's going to be positive. And notice on if I plug in a 1, I get a negative value. So at the time 1.5 seconds, my velocity goes from negative to positive. It passes through 0. Goes from negative to positive, which indicates that my particle, it's changing directions. So at what value of t does the particle change directions? It changes direction when t equals 3/2 seconds. And part F, where is the particle when S is a minimum? Okay, let's look back up here at S. Here's S, and we know the shape of this is a parabola. So S is at a minimum right down here at the vertex. So that's what we're interested in knowing. Okay, well, there's a horizontal tangent there. So remember, the derivative of position is velocity. So again, I'm looking for when the velocity is 0. When the velocity is 0, then my particle is at a minimum position. So it's when t equals 3/2 seconds. But that's not what it said. It says, where is the particle when it's a minimum? Well, that's when there's a minimum. So we just now have to evaluate S of 3/2. So when I plug it in, I get -1/4, and that would be meters. So that is the position. Okay, so kind of glancing ahead at your homework, I think these, in conjunction with the problems I did in class on Tuesday, which I'm posting those notes. Sorry, I don't have a video for that. Hopefully, I think that should get you through the homework problems. And if you have any questions, please let me know, even if you don't have to wait till class time on, as a matter of fact, I'll be there in class on Thursday, but you don't have to wait till class time. You can send me an email and I'll try and answer your questions. All right.